Log and take the log of x and all beside it. Like divide it and
All right. Today we are finishing the unit. Woo! Finishing the unit, which means next time review, and after that
Test?
the test. Wednesday. Is that what we had said? Wednesday? Let's see.
No.
Could that be right?
Wait, yes, Wednesday.
Next Wednesday?
Don't have.
Is this wrong? It's 13th is the test.
We have a flex. No, flex.
Yeah, next week is 5 days. So today's the 7th.
Thursday, no, Friday, one day.
Next
Thursday, Wednesday.
Next Thursday is the 14th, so this will be next Wednesday. Perfect. So finish it,
There's no.
review it,
Oh, it was.
have the party. Unit 7 party. 7? Is that what this is? Chapter 4 party, whatever unit. Unit 6.
Well, how are we only on chapter 4 for unit 6?
Because like chapter 2 is split into 2 different units, and there was a review chapter at the very beginning. Yes, it's a little awkward. The chapters are thick with material. Okay, so last time we talked about solving exponential equations. Today we're going to finish off the concept by not solving exponential equations, but by solving logarithmic equations. Could you just check in with your neighbor to see if they remember the 3 basic properties of logarithms? And when I say that, what I mean, the first basic one, let's not use a base, but like log of, what am I talking about?
M.
And would you please just discuss with your neighbor these 3 properties that start with this?
It's just sort of like. Yeah, and then the last is like.
Yeah.
The power. Okay. Yeah, you have to go from friends, right? Like key boss. No.
Okay, so log of m, and let's write these down. Can I call this one? Log of mn is the same thing. Oh wait, this is wrong class. The first one. And James isn't here. Shucks. But Ryan's here.
Log m plus 1. As log m plus 1.
Yeah, in this case, when it's common and we don't have to refer to the base, you can say log m plus log n, or log of m plus log of n. Do you want to finish it off? You want to do the next 2?
Oh, sure. The quotient rule.
Log of
M over n. It's just subtraction.
log of m, like minus log of n is what you're saying?
Yeah.
Okay, and the third one?
Log base b. And the argument is m to the power p. That's just p log.
Whatever the base is, right?
Yeah.
This is
The letters M and N come. Were these just ones that we chose?
good question. I've seen A and B and I've seen M and N, but I heard you say we never choose Q, and you're right.
We don't ever choose Q.
Except
we chose
P over Q.
after Q.
Yeah.
Yeah.
It's so arbitrary. I don't know.
So there's no like method. Okay.
Not that I know. We could do Q if you like. Log of QP equals log of Q plus log of P. There were some other properties, of course, things like log base A of
And
A. Let's see if we can pull together just some other important facts about logarithms. Let's bring in a base too. We need a base here.
Yeah. Yeah, and then. If it's that, and then it's a to a certain number, then it's just. Right. it's like log. It's the M, you can choose the base.
While we're at it, why don't you go ahead and just graph? Let's do a graph, shall we? Let's just bring it all. The whole log. Let's do what base shall we do? 7. I like it's a lucky number 7. Log base 7 of x.
Wait, can I change it to 3?
I think 7 is really good. Let's go with your first instinct. How many points do I want? Any particular
3.
log that?
It's less than a dash.
Remember what log base a of a is equal to? Is equal to 1. The other property we need to know is log base a of 1 is equal to
0.
0. Is there another property?
There's the one that's like when the log is in the exponent, but I forget what it's.
So it's like 6 log 6.
6 to the well, let's say a to the log base a of x like that.
Yeah.
Yeah, this is equal to x. Good. And along with that, log base a of a to the x is equal to x. You can see that's also a combination of a couple different properties. And this is because logs and exponentials are
Inverses.
you can go inverses. They just cancel out. And there was an equation. Mia, what was that equation you were talking about before class?
Oh, the like basics. Or like
Yeah, the change of base. So we could say that log base a of m is equal to, if we want a log base b,
log and
log base b,
Like the log.
log base b is on top and bottom. Log base b of m on the top and a on the bottom. That's just a different way of expressing logarithms if you want to change the base. I'm sorry, I'm kind of getting in the way of graphing that beautiful log graph.
How would that ever be useful? Because that just complicates the numbers.
This one?
Yeah.
If you had an older calculator that couldn't handle other than base 10 or base e, then that's a way to get it. Whatever base you want, common log or natural log. You're right, it's really not helpful, it's kind of antiquated at this point.
So like, in your opinion, I shouldn't use that.
I didn't say that.
Well,
You should be,
what?
you should be able to, because sometimes you can't even use it. They're probably gonna use that. They're gonna give you some inside information, huh?
I mean,
I don't know.
I feel like that would. Be great.
Oh. Maybe next, goodness.
Like, so, next time is in, this will be on the quiz next time, or next time is in?
I want to see a nice graph.
Yeah,
I feel like you're getting in the way.
no, it looks something along the line.
Longer time.
There's there's
I'm looking for a good graph of white with log base 7 of x. Just squeeze it in somewhere. I like that. I like.
and then
Oh, wait, no, it doesn't cross. It looks- It's like-
what's better, plug in.
What's the graph?
Okay, do you know what that 7 to the x looks like? How the points are like 0, 1, 1, 7. You flip those around and you have like 1, 0.
Okay, sorry.
1.
Okay, so 7, and then 1, 0, 0.
And then the one on the other side where it's like 1, 7 negative.
You get them?
Yeah. And then if you
No.
plug in, but for the other that have.
Correct, it would be 1, 7.
Yeah.
Yeah.
But then
Wait,
this.
so- Yeah. Go there.
Yeah.
Then it would be off. 7 to 9.
Yeah, exactly. So then you have this point here, this
Okay.
negative
And
1,
then some,
1, 7.
you always plug in the
When
one.
you flip that to 1, 7.
Did you get it? Did you get it?
That makes.
Yeah. Vertical.
Okay, if I get your attention, please.
Absolutely.
So this is not just something you can use in class. Like, let's say you're at a party and you run out of things to talk about. You can be like, hey, buddy, do you know how to graph y equals log base 7 of x, right? And break out the graph paper or something. And then maybe your friend starts like this.
Wrong.
Would you do something like this? Would you shake that head if you saw that?
I would make like a buzzer,
A what noise?
like a buzzer noise. Like,
Oh. Buzzer. Oh, insult to injury. No, it doesn't go to the origin. The point that we really needed to go through is specifically what point am I looking for? 1, 0. I'm definitely looking for that point on all the log based whatever functions. For this one specifically, since it's base 7, the next point that I want to see is what is it? 7, 1. Are we good with that? 7, 1?
Yeah.
And 7 is like right over here. So 1 is up here. Okay. If but I want 3 points, the last one is
1, 7.
1, 7, -1. So maybe right there. Is that we're gonna hit that y-axis?
No.
That's why the y-axis is called
Vertical acid.
vertical asymptote approaches but never touches. Something like this. That's some. Is that what you had?
Oh.
And Baron, I read that's what you were saying. It's like you weren't thinking of log base 7x when you were getting the coordinates. You were thinking about something else first, weren't you?
I was.
What is it you were thinking of?
7 to the x.
Does that make sense to think about that?
Because it's because you flip the points.
No, I get.
Yeah, this is just
Because log base 7.
But like, I get this one, but why would we ever think 7? Not something that.
not 7x, 7 to the x.
That x is very small.
No, I know. I'm just.
But the point is, from here, I think it's a little bit more intuitive. Baron, is that why you go to 7 to the x? Just like, oh yeah, if I plug in.
I just knew
one-
that, and then I just flipped the points about it. So
Right, it's pretty easy to just plug these in it, right? Get these, and then even -1 gives the 1, 7. So from those, flip them, and you automatically have the log base 7. Right when those flipped are exactly what's on our graph, correct? Okay. Okay, so just bring back some good memories there. Let's do some logarithmic equations now that we have our properties down. So logarithmic equation is an equation containing a variable in a logarithmic expression. What a surprise. I think you could already do A. Check with your neighbors, see if they can figure out how to get that answer for A. And Dylan, you're not alone, by the way. James isn't here, but you have 2 incredible people.
well,
You see it? You see what to do?
no.
Who'd like to tell us?
Yeah.
Anyone know?
Right.
I think we were able to do these when we first started talking about logs, no? We had some of these equations already. Where was it?
Oh, wait.
You see where I'm going? Yeah, like A, B, and C over there.
Wait, no. I don't know if this is good.
We did some of these.
Yes.
Yes,
No.
maybe I'm misremembering. I thought we did something like this already.
We did. Like A.
Okay, like these.
B.
Wait, here. Oh, yeah, like these. Isn't this the log equation?
I mean, like, sure.
It's definitely a logarithmic equation. It has an x and a logarithm. We did that before. It just looked a little bit more complicated. Oh, way too far back. You see it now?
Two x times two x. 4x.
You can help me out?
Kind of like.
Sure, stuff you do.
Yeah. And then we wrote on it's going to be log of B,
Can you please show me what you got for this one?
and then
For A? Okay, so 13, is that right? Is that what I'm saying? Okay, so hopefully you rewrote it in exponential form, x4 squared equals x plus 3. So now it's just 16 minus 3, right? That's where you get that
One is on
13.
your left. One is on your left.
Okay, yeah, so doing the same thing for B. Let me know when you finish it. I will be calling on someone to help us with B. The first step in B is to do what?
Where, so,
Divide by 3 first.
okay, wait, what did you do after you wrote it? Here, 2x. You can four. Right. Then one.
did everyone was second. And then.
Well, yeah.
So it's then it's long. I mean, yeah, it's for over. Yeah. That makes sense. Yeah, that's one. Because it's really. That makes sense, like algebra.
Yeah, they're good at anything.
5 seconds. Okay. Ava, can you help us out? You do B.
That divided both sides by 3.
Okay.
And then I did like the long way, and then I did log base E of 2x equals 4. And then I did e to the 4th equals 2x.
Okay.
And I got x equals e to the 4th divided by 2.
Any questions? Nicely done. That's perfect.
We can't simplify that, so that would be like a good answer on a test, right?
This is an amazing answer on the test.
Right.
Unless it says round to the nearest 10th or 1,000th or something like that, in which case you would need senior calculator or senorita. I do want you to go to a place in your mind where you can go right from here to here. Can you imagine doing that? Just
That would be a lot.
whatever you're comfortable with it. The point is get it right eventually, but I also want you to minimize your work.
Oh.
Great. Should we check it? See if it's right? No? Haters.
Well,
Sheesh. I'm checking. So Ellen, I'm gonna plug it into this. No, I'll plug it into the first one. 3 times ln of 2 times.
just you have 2, could you not just write it as e to the 4th? Could you have 2 and then it's over 2? So the 2's just cancel each other out.
See, it's so beautiful. Well, the 2's cancel each other out here. It's okay. And
Then we have to bring the 4 down.
yeah, 3 times ln of e to the 4th, bring that 4 down, so that 3 becomes
Well,
a 12. Ln of, what is ln of e?
1.
It's 1 because the base matches the
Oh, so this.
argument. So that's always 1. So 12 equals 12. It's actually not difficult to plug it in. Unless you get a decimal approximation, then it's pretty difficult. But you don't have to check it unless you want to.
Wait, can you go over the like bringing the 4 down?
Oh, sure. Well, just from the beginning, 3 times ln of 2 times our answer, e to the 4 over 2. This is parentheses, equals 12. So I hope it makes sense that the 2's cancel. Leaving us with 3 times ln of e to the 4th equals 12. And then we have that third property. Exponent becomes that coefficient. 12 equals 12. Very, very nice. Okay, so despite what I just said, after you solve any logarithmic equation, you must check for what kind of solutions. Extraneous solutions.
There's no way those are.
Be careful. Careful what you hope for.
What are we looking for?
What we are looking for is domain restriction or domain errors. When we did that quick warm up today, do I still have it here? We see that domain of logarithm. No matter what the base is, the domain is 0 to infinity. So if you get a negative number in that argument, you know that that solution has to be eliminated. Let's see. Okay, for A, what can we do with that left side? Yes, Emma. Are we good with that, everybody? That's perfect, right? That product rule of logarithms. From here, I'm going to give you a moment to finish. I will be calling on someone to help me with A. Check in with your neighbor when you're done or stuck.
Oh. No.
Did you get it? You got it? Sorry, Destiny hasn't chosen you.
Huh?
Destiny didn't choose, so I'm sorry. Okay, Lily, can you help us with B, please? I'm sorry, can you finish off A? Not B yet.
So from there, I got 2 to the power of 3 equals x times x minus 7.
Okay.
And then I distributed that x, so 8 equals x squared minus 7x, which led me to 0 equals x squared minus 7x minus 8.
Now, some people just from here say that x equals 8 and x minus 7 equals 8. Can we just do that? Exactly. No, we need a, there's no H product property. It is the 0 product property, which I think is why you said 0. So thank you. So we have x squared minus 7x minus 8 equals 0. And you got for that x equals
8 comma negative 1, but because it can't be negative, just x.
Are we good with that? All right, double check to make sure neither of these make any sort of domain issues. And you can see log base 2 of -1 doesn't work. And also in the other one doesn't work. You plug in -1. -1 is just all bad. Our only answer is 8. Shall we check it? It's probably okay, but let's check it just for fun. Because we live on the edge like that.
Question.
Yes.
Could you ever just like, if you had the term ln on both sides, could you just divide by ln?
If it were a factor, yes, but it's not a factor. So you have to be careful. Thank you for reminding us of that. Okay, I'm gonna check this. Log base 2 of 8
Then B, I have L.
plus log base 2 of 1. Does that really equal 3? Does it?
Yes.
You sure? How do you know? Just check it with your neighbor. How do you know that this is true?
For this, yeah.
What can be 8 x?
Oh, yeah, because the third is, and then one is just zero, you have to find like the common.
Is it plain as day that it's true?
Yeah.
Because we know log base 2 of 8 is 3. We know log base 2 of 1 is 0. So we know that 3 plus 0 is 3. It's so obviously true once you evaluate those things. So that's a good check. That part isn't necessary unless you really want to make sure everything's right, but you do have to check to make sure there's no domain issue. That's why that -1 is just thrown out the window. Okay, B, you might be tempted to divide by ln, but since it's not a factor, we can't. So this, but the strategy is a little bit different. Yeah, do you have an
But
idea?
after you combine them, then is it a factor?
Ah, after you combine, select that left side, make this ln of
X plus 2 over 4x plus 3.
nice, using that quotient property. Now, it's not that we could divide them, but we could tell by observation, since you have an ln on the left and ln on the right. We could just say that they're equivalent, so their what's are equivalent. The arguments are equivalent. Don't try to make this an exponential equation. Don't do like e to the something here. Although that will work too. X plus 2 over 4x plus 3 equals 1 over x. I'll give you a minute to finish that. Is this new? Because the first is just making sure. I don't remember seeing this. I'm just making sure that you all saw it. In case there was any question.
Yeah, negative.
Oh, so you multiply by the. Yeah. Like multiple percent, I just call 0 equals x minus 2 equals 3. X minus 3 equals 2. X equals 3 and 1.
Did you get it? You get an answer? Yeah, I need some chat. I need some help. Mia, your dream came true.
Yeah, so, I just, cross multiplied, so it's x squared plus 2x equals 4x plus 3.
Okay.
After I took out all equals to 0, and then I just factored, and then the factors were, or x equals 3 on the 1. And,
Just a minute. Are we okay with this? We get x equals 3 negative 1. Okay, and then keep going.
and then it came to be a negative, so it's just x.
Oh, that kind of sucks. It is what it is. Shall we check? Or do we just, should we accept that that's true? It's kind of living on the edge if you don't check it, but I'll say I buy it. Let's see, what would it be? ln of 5 over, I have to go all the way back.
Or ln of 6.
ln of 5 minus ln of 15 equals ln of 1/3. It is true. 5 over 15, 1/3. Okay. Thank you, Mia. 2 more questions. Medical research indicates that the risk of having a car accident increases exponentially by the concentration of alcohol in the blood. So as the concentration of alcohol in the blood increases. The risk is modeled by R equals 6 times e to the 12.77 x, where x is the blood alcohol concentration, and R, given as a percent, the risk of having a car accident. What blood alcohol concentration corresponds to a 17% risk of a car accident? How is this shown on figure at right?
They're allowed to say that it means a 100% chance of a car accident. If it gets to the top at 0.22, it's
And it's a mathematical model, so you have to take it with a grain of salt. So how do I start? When am I gonna do it? That 17?
that it's R.
Should I do 17 or 0.7? But it says given as a percent, so not as a decimal. So there's gonna be 17 equals 6 times e to the 12.77 x. I'll give you a chance to figure that out. You will need a calculator for this one. That's something. Okay.
Right. Oh. Make it a lot.
Okay, did you get it?
You have 7. How do you get that?
You ready? Give me 10 seconds. We gotta finish this up.
Wait.
Okay, I just have one more problem after this.
Oh, wait.
Okay. Emma, can you help me out with this one, please? Thank you.
First part is, well, when you look up the e to the 12.77. X is sentence number 6.
I'm with you on the variables on the left. Yeah.
I 12.77 X, like in front of the E. It's
Can we do that? There's no log there, so we can't move that yet.
okay, so. Ln on both sides.
We could take the ln on both sides. That's a nice choice. I like it. So you have, I'm gonna squeeze that in here and here.
So when
Okay.
you want to pick the log, you have log of E or log of E.
Whatever you like. I think ln is a great choice here. And what happens when you take the ln on both sides?
Basic. I thought it was.
Nice.
Yeah, 12.77.
So I think I'm doing this in my head, so tell me if I'm right. Did I do that right?
That's why I was, yeah.
Okay, did you get a numerical value? 0.08. Are we good with this? Nicely done. Yes, Sienna?
We didn't do exactly that. We took like ln, or we like converted the exponential to ln and got C.
Love it. Isn't that cool?
Oh, okay.
Right from here, you recognize as exponential, so you put it into logarithmic form. I love it, especially since we have a base that we're familiar with logarithms. Yeah, from here we could say ln of 17.6 is equal to 12.77 x. That gives us the exact same place, which I think it's comforting as long as you're doing something right, you're gonna get some good answer. The 0.08 represents the blood alcohol level that would yield a 17% chance of crashing on the way home.
You're saying if you were like legally drunk, you would have said chance of crashing.
Yeah,
I feel like it's a lot lower odds than they hype it up.
So it'd be 0.0.
I think it's different for everybody. Like on average.
No
one's getting a car with Bear.
I think the point is,
Not gonna drink and drive.
yeah, the point is, first of all, don't drink. Second of all, definitely don't drink and drive. Maybe don't even drive. Just stay home. Just stay home and play video games. That's the moral of the story. Okay. Ooh, compounded interest. Do you remember doing this? We did this like a few weeks ago. Can you remember? Can you talk about the formula about compound interest with your neighbors? See if you can bring it back. It starts with A. Compounded monthly.
Or
Like,
the end to the end. To the end.
and then. Oh, A. That's it.
Okay, so what is the A equal?
A equals P times 1 plus R over M to the end.
And then, yeah.
Are we good with this?
Like
Extra credit for remembering. Very, very nice.
actual extra credit.
Nice, like in the spirit of extra credit. Okay, yeah, there it is. That is the formula. Can you put all the pieces where they belong?
These. Oh, right.
Yes. Okay. Yeah.
Wait, A is, oh,
Right? Two.
You will need a calculator for this problem.
There's one, no, yeah, I think it's one.
okay, wait. Not. One.
Yeah.
Yeah.
Okay, cool. I don't know what to do
One.
next.
Oh,
Yeah.
I do recommend using your calculator only on the very last step. I do everything just by hand first, and then calculator is the last step only.
Yeah. How do you spell that?
You have to log it. I think.
Yeah.
Time is running short. I'm gonna write it up here. Do you start with 10 million? I started with 10 million
Yeah.
equals 50,000
Really, sure.
times the quantity of 1 plus 0.09 over 12 to the 12 e. Next step, divided by 50,000, which gives you 200. Let's see if I cross out these 4, unless it's 100 divided by 5. Oh, it's just 20 equals 1 plus 0.09 over 12 to the 12t. I'm not gonna calculate that mess because I don't have a calculator. Next step. Well, not yet. I want to get a t equals and then put everything in our calculator. You're right, and you could do that inside. Actually, I know 9/12 is the same thing as 3/4, so it's 0.75, so it's point
Yeah.
oh, 0.075. So 1.0. Yeah, it's not some, it's like this
We
much.
calculate for that, or should we go?
You can use a calculator for that part. But from there, next step. You want to take the ln of both sides? The log of both sides? Do you want to just change it into logarithm base 1.0075?
Yeah.
You could do whatever you want. I'm gonna do just the ln of both sides because ln is shorter than log. So ln of 20 is equal to, and instead of ln, I'm just gonna do 12t ln of 1.0075. I hope that's comfortable. So t is equal to ln of 20 over 12 times ln of 1.0075. Exact
the answer.
That is the exact answer. Which I'm guessing is what, 3-4 years? To go from 5 to 2,000 a million?
That's
What is that? About 80 years or something? I have no idea. And do I remember how to get to the fraction function on your calculator? Alpha. I think the quickest way is alpha and then the variable alpha x should get you there. But you're right, the math.
no, that's to get you to log with a constant. That's like if you want to put in like log.
Anyone get
base
it?
7, you have to do.
What'd you get?
No, I was just like,
Oh, you know how to do it. Did anyone get the number?
I got 33.
33.4. Sasha, did you get 2? Did anyone else get it? 33.4? Okay. Oh, interesting. That's
33 years.
not bad.
I am
I'll
good to
put-
do this.
That's worth it.
And 9% a month is a lot.
That's 9% a year, but that 9% is divided into a bit, so you get a little piece every month. Right, that's why you take that 9 and divide it by 12. Yes, Ava,
Technically natural laws, which is like the law.
doesn't matter at all. You get the same thing.
So when you said ln of both sides, I could have said log of both sides.
Yeah. You could have said log base 5 of both, or log base 7 of both sides. Whatever log you want. Yeah.
So I think for the homework, like last time, it had to be like the natural log, like it
But
was
it
in
meant-
like the answers, right, but it's not in like the right form, and that made you do like the.
Yeah, that's annoying. I'm sorry.
But at least you put in 2.5 and I told you it was wrong.
Oh, yeah, it's gotta be 5/2.